Part 3 of Cosmos, a sketch of the physical description of the universe, Introduction, by Alexander von Humboldt. This LibriVox recording is in the public domain. In the earliest stages of civilization, the grand and imposing spectacle presented to the minds of the inhabitants of the tropics could only awaken feelings of astonishment and awe. It might, perhaps, be supposed, as we have already said, that the periodical return of the same phenomena, and the universal manner in which they arrange themselves in successive groups, would have enabled man more readily to attain to a knowledge of the laws of nature. But as far as tradition and history guide us, we do not find that any application was made of the advantages presented by these favored regions. Recent researches have rendered it very doubtful whether the primitive seat of Hindu civilization, one of the most remarkable phases in the progress of mankind, was actually within the tropics. Aryana Vajo, the ancient cradle of the Zend, was situated to the northwest of the upper Indus, and after the great religious schism, that is to say, after the separation of the Iranians from the Brahminical institution, the language that had previously been common to them and to the Hindus assumed among the latter people, together with the literature, habits, and condition of society, an individual form in the Magadha or Mayadisa, a district that is bound by the great chain of Himalaya and the smaller range of the Vindhya. In less ancient times, the Sanskrit language and civilization advanced toward the southeast, penetrating further within the torrid zone, as my brother Wilhelm von Humboldt has shown in his great work on the Kavi and other languages of analogous structure. Notwithstanding the obstacles opposed in northern latitudes to the discovery of the laws of nature, owing to the excessive complication of phenomena and the perpetual local variations that in these climates affect the movements of the atmosphere and the distribution of organic forms, it is to the inhabitants of a small section of the temperate zone that the rest of mankind owe the earliest revelation of an intimate and rational acquaintance with the forces governing the physical world. Moreover, it is from the same zone, which is apparently more favorable to the progress of reason, the softening of manners, and the security of public liberty, that the germs of civilization have been carried to the regions of the tropics as much by the migratory movement of the races as by the establishment of colonies, differing widely in their institution from those of the Phoenicians or Greeks. In speaking of the influence exercised by the succession of phenomena on the greater or lesser facility of recognizing the causes producing them, I have touched upon that important stage of our communion with the external world, when the enjoyment arising from a knowledge of the laws and the mutual connection of phenomena associates itself with the charm of a simple contemplation of nature. That which for a long time remains merely an object of vague intuition, by degrees acquires the certainty of positive truth, and man, as an immortal poet has said, in our own tongue, amid ceaseless change seeks the unchanging pole. In order to trace to its primitive source the enjoyment derived from the exercise of thought, it is sufficient to cast a rapid glance on the earliest dawnings of the philosophy of nature, or of the ancient doctrine of the cosmos. We find even among the most savage nations, as my own travels enable me to attest, a certain vague, terror-stricken sense of the all-powerful unity of natural forces, and of the existence of an invisible, spiritual essence manifested in these forces, whether in unfolding the flower and maturing the fruit of the nutrient tree, in upheaving the soil of the forest, or in rending the clouds with the might of the storm. We may here trace the revelation of a bond of union, linking together the visible world and that higher spiritual world which escapes the grasp of the senses. The two become unconsciously blended together, developing in the mind of man as a simple product of ideal conception, and independently of the aid of observation, the first germ of a philosophy of nature. Among nations least advanced in civilization, the imagination revels in strange and fantastic creations, and by its predilection for symbols alike influences ideas and language. Instead of examining, men are led to conjecture, dogmatize, and interpret supposed facts that have never been observed. The inner world of thought and of feeling does not reflect the image of the external world in its primitive purity. That which in some regions of the earth manifested itself as the rudiments of natural philosophy only to a small number of persons endowed with superior intelligence, appears in other regions and among entire races of men to be the result of mystic tendencies and instinctive intuitions. An intimate communion with nature and the vivid and deep emotions thus awakened are likewise the source from which have sprung the first impulses toward the worship and deification of the destroying and preserving forces of the universe. But by degrees, as man, after having passed through the different gradations of intellectual development, arrives at the free enjoyment of the regulating power of reflection, and learns by gradual progress, as it were, to separate the world of ideas from that of sensations, he no longer rests satisfied merely with a vague presentiment of the harmonious unity of natural forces. Thought begins to fulfill its noble mission, and observation, aided by reason, endeavors to trace phenomena to the causes from which they spring. The history of science teaches us the difficulties that have opposed the progress of this active spirit of inquiry. Inaccurate and imperfect observations have led, by false inductions, to the great number of physical views that have been perpetuated as popular prejudices among all classes of society. Thus, by the side of a solid and scientific knowledge of natural phenomena, there has been preserved a system of the pretended results of observation, which is so much the more difficult to shake, as it denies the validity of the facts by which it may be refuted. This empiricism, the melancholy heritage transmitted to us from former times, invariably contends for the truth of its axioms with the arrogance of a narrow-minded spirit. Physical philosophy, on the other hand, when based upon science, doubts because it seeks to investigate, distinguishes between that which is certain and that which is merely probable, and strives incessantly to perfect theory by extending the circle of observation. This assemblage of imperfect dogmas, bequeathed by one age to another, this physical philosophy which is composed of popular prejudices, is not only injurious because it perpetuates error with the obstinacy engendered by the evidence of ill-observed facts, but also because it hinders the mind from attaining to higher views of nature. Instead of seeking to discover the mean or medium point around which oscillate in apparent independence of forces all the phenomena of the external world, this system delights in multiplying exceptions to the law, and seeks, amid phenomena and in organic forms, for something beyond the marvel of a regular succession and an internal and progressive development. Ever inclined to believe that the order of nature is disturbed, it refuses to recognize in the present any analogy with the past, and, guided by its own varying hypotheses, seeks at hazard, either in the interior of the globe or in the regions of space, for the cause of these pretended perturbations. It is the special object of the present work to combat those errors which derive their source from a vicious empiricism and from imperfect inductions. The higher enjoyments yielded by the study of nature depend upon the correctness and the depth of our views, and upon the extent of the subjects that may be comprehended in a single glance. Increased mental cultivation has given rise, in all classes of society, to an increased desire of embellishing life by augmenting the mass of ideas and by multiplying means for their generalization. And this sentiment fully refutes the vague accusations advanced against the age in which we live, showing that other interests besides the material wants of life occupy the minds of men. It is almost with reluctance that I am about to speak of a sentiment which appears to arise from narrow-minded views, or from a certain weak and morbid sentimentality. I allude to the fear entertained by some persons that nature may by degrees lose a portion of the charm and magic of her power, as we learn more and more how to unveil her secrets, comprehend the mechanism of the movements of the heavenly bodies, and estimate numerically the intensity of natural forces. It is true that, properly speaking, the forces of nature can only exercise a magical power over us as long as their action is shrouded in mystery and darkness, and does not admit of being classed among the conditions with which experience has made us acquainted. The effect of such a power is, therefore, to excite the imagination, but that assuredly is not the faculty of mind we would evoke to preside over the laborious and elaborate observations by which we strive to attain to a knowledge of the greatness and excellence of the laws of the universe. The astronomer who, by the aid of the heliometer or a double refracting prism, determines the diameter of planetary bodies, who measures patiently, year after year, the meridian altitude and the relative distance of stars, or who seeks a telescopic comet in a group of nebulae, does not feel his imagination more excited, and this is the very guarantee of the precision of his labors, than the botanist who counts the divisions of the calyx, or the number of stamens in a flower, or examines the connected or the separate teeth of the peristoma surrounding the capsule of a moss. Yet the multiplied angular measurements on the one hand, and the detail of organic relations on the other, alike aid in preparing the way for the attainment of higher views of the laws of the universe. We must not confound the disposition of mind in the observer at the time he is pursuing his labors with the ulterior greatness of the views resulting from investigation and the exercise of thought. The physical philosopher measures with admirable sagacity the waves of light of unequal length, which by interference mutually strengthen or destroy each other, even with respect to their chemical actions. The astronomer, armed with powerful telescopes, penetrates the regions of space, contemplates, on the extremest confines of our solar system, the satellites of Uranus, or decomposes faintly sparkling points into double stars, differing in color. The botanist discovers the constancy of the gyratory motion of the chara in the greater number of vegetable cells, and recognizes in the genera and natural families of plants the intimate relations of organic forms. The vault of heaven, studded with nebulae and stars, and the rich vegetable mantle that covers the soil in the climate of palms, cannot surely fail to produce on the minds of these laborious observers of nature an impression more imposing and more worthy of the majesty of creation than on those who are unaccustomed to investigate the great mutual relations of phenomena. I cannot, therefore, agree with Burke when he says, "It is our ignorance of natural things that causes all our admiration, and chiefly excites our passions." While the illusion of the senses would make the stars stationary in the vault of heaven, astronomy, by her aspiring labors, has assigned indefinite bounds to space; and if she have set limits to the great nebula to which our solar system belongs, it has only been to show us in these remote regions of space, which appear to expand in proportion to the increase of our optic powers, islet on islet of scattered nebulae. The feeling of the sublime, so far as it arises from a contemplation of the distance of the stars, of their greatness and physical extent, reflects itself in the feeling of the infinite, which belongs to another sphere of ideas included in the domain of mind. The solemn and imposing impressions excited by this sentiment are owing to the combination of which we have spoken, and to the analogous character of the enjoyment and emotions awakened in us, whether we float on the surface of the great deep, stand on some lonely mountain summit, enveloped in the half-transparent vapory veil of the atmosphere, or by the aid of powerful optical instruments scan the regions of space and see the remote nebulous mass resolve itself into whirls of stars. The mere accumulation of unconnected observations of details devoid of generalization of ideas may doubtlessly have tended to create and foster the deeply rooted prejudice that the study of the exact sciences must necessarily chill the feelings and diminish the nobler enjoyments attendant upon a contemplation of nature. Those who still cherish such erroneous views in the present age, and amid the progress of public opinion and the advancement of all branches of knowledge, fail in duly appreciating the value of every enlargement of the sphere of intellect, and the importance of the detail of isolated facts in leading us on to general results. The fear of sacrificing the free enjoyment of nature under the influence of scientific reasoning is often associated with an apprehension that every mind may not be capable of grasping the truths of the philosophy of nature. It is certainly true that in the midst of the universal fluctuation of phenomena and vital forces, in that inextricable network of organisms by turns developed and destroyed, each step that we make in the more intimate knowledge of nature leads us to the entrance of new labyrinths. But the excitement produced by a presentiment of discovery, the vague intuition of the mysteries to be unfolded, and the multiplicity of the paths before us, all tend to stimulate the exercise of thought in every stage of knowledge. The discovery of each separate law of nature leads to the establishment of some other more general law, or at least indicates to the intelligent observer its existence. Nature, as a celebrated physiologist has defined it, and as the word was interpreted by the Greeks and Romans, is that which is ever growing and ever unfolding itself in new forms. The series of organic types becomes extended or perfected in proportion as hitherto unknown regions are laid open to our view by the labors and researches of travelers and observers, as living organisms are compared with these which have disappeared in the great revolutions of our planet, and as microscopes are made more perfect and are more extensively and efficiently employed. In the midst of this immense variety and this periodic transformation of animal and vegetable productions, we see incessantly revealed the primordial mystery of all organic development, that same great problem of metamorphosis which Goethe has treated with more than common sagacity, and to the solution of which man is urged by his desire of reducing vital forms to the smallest number of fundamental types. As men contemplate the riches of nature and see the mass of observations incessantly increasing before them, they become impressed with the intimate conviction that the surface and the interior of the earth, the depths of the ocean, and the regions of air will still, when thousands and thousands of years have passed away, open to the scientific observer untrodden paths of discovery. The regret of Alexander cannot be applied to the progress of observation and intelligence. General considerations, whether they treat of the agglomeration of matter in the heavenly bodies, or of the geographical distribution of terrestrial organisms, are not only in themselves more attractive than special studies, but they also afford superior advantages to those who are unable to devote much time to occupations of this nature. The different branches of the study of natural history are only accessible in certain positions of social life, and do not, at every season and in every climate, present like enjoyments. Thus, in the dreary regions of the north, man is deprived for a long period of the year of the spectacle presented by the activity of the productive forces of organic nature, and if the mind be directed to one sole class of objects, the most animated narratives of voyages in distant lands will fail to interest and attract us, if they do not touch upon the subjects to which we are most partial. As the history of nations, if it were always able to trace events to their true causes, might solve the ever-recurring enigma of the oscillations experienced by the alternately progressive and retrograde movement of human society, so might also the physical description of the world, the science of the cosmos, if it were grasped by a powerful intellect and based upon a knowledge of all the results of discovery up to a given period, succeed in dispelling a portion of the contradictions which at first sight appear to arise from the complication of phenomena and the multitude of the perturbations simultaneously manifested. The knowledge of the laws of nature, whether we can trace them in the alternate ebb and flow of the ocean, in the measured path of comets, or in the mutual attractions of multiple stars, alike increases our sense of the calm of nature, while the chimera, so long cherished by the human mind in its early and intuitive contemplations, the belief in a discord of the elements, seems gradually to vanish in proportion as science extends her empire. General views lead us habitually to consider each organism as a part of the entire creation, and to recognize in the plant or animal not merely an isolated species, but a form linked in the chain of being to other forms either living or extinct. They aid us in comprehending the relations that exist between the most recent discoveries and those which have prepared the way for them. Although fixed to one point of space, we eagerly grasp at a knowledge of that which has been observed in different and far distant regions. We delight in tracking the course of the bold mariner through seas of polar ice, or in following him to the summit of that volcano of the Antarctic pole, whose fires may be seen from afar, even at midday. It is by an acquaintance with the results of distant voyages that we may learn to comprehend some of the marvels of terrestrial magnetism, and be thus led to appreciate the importance of the establishments of the numerous observatories which in the present day cover both hemispheres, and are designed to note the simultaneous occurrence of perturbations and the frequency and duration of magnetic storms. Let me be permitted here to touch upon a few points connected with discoveries whose importance can only be estimated by those who have devoted themselves to the study of the physical sciences generally. Examples chosen from among the phenomena to which special attention has been directed in recent times will throw additional light upon the preceding considerations. Without a preliminary knowledge of the orbits of comets, we should be unable duly to appreciate the importance attached to the discovery of one of these bodies, whose elliptical orbit is included in the narrow limits of our solar system, and which has revealed the existence of an ethereal fluid tending to diminish its centrifugal force and the period of its revolution. The superficial half-knowledge, so characteristic of the present day, which leads to the introduction of vaguely comprehended scientific views into general conversation, also gives rise, under various forms, to the expression of alarm at the supposed danger of a collision between the celestial bodies or of disturbance in the climatic relations of our globe. These phantoms of the imagination are so much the more injurious as they derive their source from dogmatic pretensions to true science. The history of the atmosphere and of the annual variations of its temperature extends already sufficiently far back to show the recurrence of slight disturbances in the mean temperature of any given place, and thus affords sufficient guarantee against the exaggerated apprehension of a general and progressive deterioration of the climates of Europe. Encke's comet, which is one of the 3 interior comets, completes its course in 1200 days, but from the form and position of its orbit, it is as little dangerous to the earth as Halley's great comet, whose revolution is not completed in less than 76 years, and which appeared less brilliant in 1835 than it had done in 1759. The interior comet of Biela intersects the Earth's orbit, it is true, but it can only approach our globe when its proximity to the sun coincides with our winter solstice. The quantity of heat received by a planet, and whose unequal distribution determines the meteorological variations of its atmosphere, depends alike upon the light-engendering force of the sun, that is to say, upon the condition of its gaseous coverings and upon the relative position of the planet and the central body. There are variations, it is true, which, in obedience to the laws of universal gravitation, affect the form of the earth's orbit and the inclination of the ecliptic, that is, the angle which the axis of the earth makes with the plane of its orbit. But these periodical variations are so slow and are restricted within such narrow limits that their thermic effects would hardly be appreciable by our instruments in many thousands of years. The astronomical causes of a refrigeration of our globe and of the diminution of moisture at its surface, and the nature and frequency of certain epidemics, phenomena which are often discussed in the present day according to the benighted views of the Middle Ages, ought to be considered as beyond the range of our experience in physics and chemistry. Part 4.